Hello guys, in this video we're going to be going over IXL section K.2 underneath the Algebra 2 subject. This topic is adding and subtracting polynomials. So when we add and subtract polynomials, the most important thing to keep in mind is that we can only add to or take away from like terms. So what is a like term? It's a algebraic term that is the same, that has the same variable and the same power. So when we look at this example, we see that we have a 4v right here, and we have a 7v right there. These are going to be like terms because they both have a v in them, and they both have a degree or a power of 1. Because they have the same variable and they have the same power, that means that we can go ahead and add and subtract these. So over here, I can write equals, and just to keep it color-coded, this is going to be 4v plus 7v. You can think of this just like any item. You know, if you have four pencils plus 7 pencils, well, you would now have 11 pencils, or 11v. Right? They are the same thing, so we can go ahead and add them. The same way that you can count cats or dogs or any kind of thing. We count 4v's, we count 7v's, that brings us to 11v's. Okay, let's go ahead and also, and we'll keep it color coded. So we do also have another term in here, and this is our term with no variable on it. This is our 3 and our 11. And you probably already know how to add numbers like this, but notice it's just like it's just like when something has a variable, you know, we count it all the same. We have 3 of something, we have 8 of something, so that's going to mean that total we have 11 of something. And then we'll go ahead, we'll just add a plus sign right there. Our 11 technically is positive, so that's why we would put the plus right there. And so our final answer should be 11v. That's not correct. We'll delete these. 11v. There we go. And then plus 11. Okay, let's go ahead and submit that. Okay, so the main thing there was our like terms. We want to identify our like terms. We can then go ahead and just combine them as normal, adding the coefficients. Alright, so I have 5n squared, and I have 9n squared. I notice those are the same kind of terms, so I'll add them over here. 5 plus 9 is going to be 14n squared. Okay, make sure you don't lose your variable and your power. Also make sure you don't change your power, right? Changing your power would make it a different kind of term, and just because we add things together, they don't become new terms, right? You cannot add cats with dogs and get dogs, or you cannot add elephants with elephants and get monkeys. You know, that wouldn't make sense. Okay, so likewise, we can identify that we have just a number with no variable, a 2 and a 2. So 2 plus 2 is going to be 4. I'll add this to the end because I notice I have an n term which can fit nicely in the middle, and I prefer to keep my polynomials ordered by degree. So we're then going to have one term left over, a 4n. It has no one to add with, so it just stays the same, and we have 4n right there. Okay, so this is going to be our final expression. All right, 14n squared plus 4n plus 4. Cool, looks good. Let's hit submit, and it is correct. Okay, so subtracting can be a little bit different of a ball game. And actually, I kind of just like to think of it all as the same thing, except with positives and negatives. Now, how do you do that? Well, if you're subtracting something, that really just means that you're going to combine the opposite of it. And in math terms, this just means that you can go ahead and distribute the negative. So we can rewrite this as 6h plus 5. That's our first term from right there. And then we're going to have a negative 6h. Negative 6h and a negative 5. Okay, our negative was distributed, and now we can just think of it as combining things together. And when we start to combine these together, you notice that, well, 6h and negative 6h, those are opposites. That's like having $6 and then losing $6, and so you would have 0 left over. And then 5 and negative 5 are also opposites. So those would cancel with each other as well, and we actually see that everything's going to cancel here, which means that we have 0. Okay, so same deal here. We're going to go ahead and add these together. Now, this one might pose a little bit of a trick to you because you might look at this and try to combine your like terms and say, well, wait a second, I don't have any like terms. I just have a squared term, an a term, and a constant term, or just a pure number term. So what do I do with that? Well, it's actually really easy. All you have to do is just write them together, no parentheses, and, well, that's your polynomial. Now, why do you stop right there? It's because none of these are the same terms, and it cannot be combined anymore. We cannot go ahead and write 6a squared trying to combine these two things, and we also cannot write 6a. And a squared is not an a, so we can't add them together. And even more so, if we added an a squared with an a, which one of these would it become? So you see, the logic kind of starts to break down if we start to add things that are not like terms. So when we have things that aren't like terms, we just keep them next to each other. There's no more work to be done. So our final answer is a squared plus 5a plus 4. That looks correct. Okay, so same deal right here, except now I'm subtracting. Again, I like to go ahead and I like to distribute this negative, so that way I'm not thinking about adding and subtracting, I'm just thinking about positives and negatives, which technically they're all the same thing, but now you don't have to worry about any pesky signs potentially messing you up. Okay, so distributing the negative, I will have negative 7b plus 2. Oops. And I actually made a small typo. Right? Hopefully you can catch that. If so, kudos to you. This is actually supposed to be a negative 2. Because remember, my negative will distribute even to my 2. Now I'll go ahead and I'll combine my like terms. I see that my b squared term does not have any like terms, so this will just be b squared. I see that my 8b and my negative 7b, well, those can combine together, and I have 8 of something, and I have negative 7 of that same thing, or $8 of actual money and $7 of debt. That produces just a single dollar, or a single b. And I have 8 minus 2, well, that's like having $8 and spending $2, and you just have 6 left over. So my final answer is b squared plus b plus 6. This is really good handwriting software. It's very accurate. Alright, so same deal. So, I think it's better if you go ahead and distribute the negative. Again, you don't have to do this, but then realize, if you're subtracting, like, let's say, well, we can look at it later, but, say we had like 5 minus 6, you would have to remember that 5 minus 6 is going to be a negative number. Okay, so this will equal 7j plus 5, and then distributing our negative, we will have negative 6j minus 4. We can now go ahead and start to combine our like terms. I have a 7j and a negative 6j. That's going to make just a single j, and I can write just j, or if you want, you could even put a 1 in front of there. There's nothing wrong with that. Now we'll also combine our 5 and our negative 4, and this will make a plus 1. Okay, so our final answer, our final answer is just going to be j plus 1. Okay, same deal. We're going to look for our like terms. So we have some u squareds. We'll go ahead and add those. 5 and 5 is going to make 10 u squared. We have a number and a number, just a constant and a constant. So that will make a 8. And then I have my u left over, so I'm just going to tack that on. Nothing was added with it, so it stays on its own. Now notice I wrote this out of order, meaning that I didn't write it in order of their powers. Now, it's technically still correct. However, as mathematicians, it's always good to be organized, and you should always try and write your work from highest power to lowest power. And to even test out that this version still is correct, we'll go ahead and write that in there. So we have 10u squared plus 8 plus 6u. Ooh, not bu. That is not correct. No, let's write that. 10u squared plus 6u plus 8. Oh, no. I wanted to make the point. I wanted to show you guys. So, sorry. So 10u squared plus 8 plus 6u. Cool. We go ahead and submit that and see it took the answer that is correct. Writing it out of order is okay, but it's not organized. Okay, so same deal. We'll go ahead and look for our like terms. I see a y term. So 8y and 1y is going to make, not 7y. It's going to make 9y. And then a negative 7 and a negative 3, well, that's like debt with more debt. So if I'm in debt $7 and I go further into debt $3 more, well, now I'm in debt $10. And I have a y to the third power. There's nothing else to go with that, so I'll just write plus y cubed. And then I have a y squared, so I'll just write minus 3y squared. And I actually just noticed, I'm sorry, that was a small typo. I dropped the 7. That is plus 7y cubed. Okay, that is our final answer. Again, it's not written in order. In order, it would look like this. 7y cubed minus 3y squared plus 9y minus 10. But again, remember the order, it is still correct if it is not written in order. It's just disorganized. Alright, so that is my final answer right there. We'll go ahead and submit it. Okay, so again, I have subtraction, and when I have subtraction, I like to go ahead and distribute that negative. That's going to give me a negative 7h squared plus 4h minus 4. Notice I just wrote that first term again, and then my negatives are going to be negative 4h squared. Now be careful, we have a negative of a negative. And like we've gone over before, if a bad thing happens to a bad person, is that good or bad? If we kill Hitler, well, we're happy about that. So a negative of a negative would make a positive, meaning this would be a positive 2. So we can now go ahead, combine our like terms, and I have a h squared and an h squared, both of which are negative. So remember, -$7 and -$4. Well, I'm still in debt. It's just debt with more debt. So I have -11 h squared. And I have a h term right here. Notice it doesn't have anything to pair up with. So we're just going to write plus 4h. And then we have our constants right here. A -4 and a +2. That's going to make a -2. It's like being in debt $4 and then having $2 of actual money. So how much money do you really have? Okay, so our final answer is going to be -11 h squared plus 4h minus 2. Okay, so again, notice with this one, we don't have any like terms here. We have a g squared, we have a g, and we have a constant, none of which are like terms. So my final answer is just going to be all of these rewritten. And if you're wondering, yes, you could actually write it just in the order that it was given to you. But, you know, it's good to be organized, and I'll go ahead and write this in order. Alright, so we have a negative here. Let's go ahead and distribute that. So that will give me a 8a squared plus 8a plus 4. And now remember my negative. This will be a minus a squared minus 4a minus 1. So I'll go ahead, identify my like terms, and combine them. I have an a squared and an a squared. So 8a squared minus a squared is going to be 7a squared. I have a and an a. 8a minus 4a is going to be 4a. And then a constant and a constant, 4 minus 1, is just going to be 3. A positive 3. Okay, and that answer should be correct. Nice. Okay, alright, so same deal, we're looking for our like terms. So I notice that's my only cubic term, or my only term with the power of 3. So that will be left over. I have a square term right there, and notice there's no other square term to go with it. And then I have a constant term, and well, my constants can add together. But then aside from that, I have an s term, and that also has no one. So these two numbers are the only thing that are going to be adding together. So I'm literally going to get, again, 8s cubed plus 8s squared. And now I'll go ahead, I'll put my s term, 4s, and then plus 9. Okay, I just added my 1 and 8, and that's how I got 9. We'll go ahead, I guess, let's take it to an 80. So we'll go ahead, we'll distribute our negative. This will then become a -4n minus 5. And then our negative will make a -4n squared. And don't forget, a negative of a negative, if we do a bad thing to a bad person, we kind of consider that good, right? We punish criminals. And so a negative of a negative makes a positive, so we get plus 2n. So I have n in n terms. So this would be equal to -4 and +2. That will make -2n. And then I have a -5 that does not have another number to combine with. And I have a -4n squared. That's the only n squared I have. So I'll just have -4n squared. And remember, the order does not matter, though it's always good to be organized. Okay. Alright, so I look at this and, again, we're combining like terms. So I have a t squared and a t squared. That is going to make 14t squared. I have a t and a t. We can combine those together and get plus 10t. And then we have just a 1, nothing to combine with that, so just plus 1. So our final answer is 14t squared plus 10t plus 1. Okay? We'll go ahead and conclude the video right there.